Hi, welcome back. This is the second part of a two-part series on SVG drag and drop with Angular. If you haven't watched the first part, link below. Otherwise, let's get started. So let's get started on the actual drag and drop then. So what we need to do is add in some event handlers. What I'm going to do actually is I'm going to handle the events for when you click down on something, when the mouse is moving and you click down on something, and when you have clicked up, so when you basically release the mouse button. So click down, drag, click up, that's the formula for drag and drop. So let's handle those three events. So in our SVG, we're going to handle it kind of at the top level. All those events are going to bubble up to the SVG. So for the mouse down button, left mouse button is pointed down, and that's what we want to handle when you click. And then let's just call it pointer down. That's going to be the name of our function that we use to handle it, and this supplies us with the event parameter, which is basically it will be to do with the actual mouse position and the thing that it clicked on, the event target, and so on and so forth. So we know what we clicked on and where we clicked, etc., etc. Okay, so that'll be our pointer down. Then we also want to do when it's actually moving, so we want to point and move, because as you're dragging and dropping, you're obviously moving the mouse. We want to know where it is, and let's call this pointer move. We like camel case, it's a bit more sensible when you read it. Handle that one, pointer move, and we also want then like the pointer up, which is going to be basically when you've dragged it and you dropped it. So the drop is the pointer up. Pointer up equals pointer up, and okay, we need to implement these three functions. Equals $event. Cool, the magic $event, which is all the information we'll get passed through. Save that guy. Didn't want to compile, no, because we haven't implemented the functions. Useful, so let's implement these now. Let's just see if we can just get rid of that. Control and B for get rid of the navigator there, and let's just see if we could do this. It's a little bit small, but never mind. Maybe we can just move it over. It's nice to be able to see things side by side. So we've got three events we need to implement. Here we go. Let's do the first one. Point it down. And we should take an event parameter, and like so, and then being lazy, as you know I am, pointer move, which also takes an event, and pointer up, which takes an event, and that should appease the gods of Angular and let us compile. No, what didn't I do? Pointer move does not exist on, did you mean pointer move? No, did I? Must have spelled it wrong. Did like an idiot. Put the wrong one in. There we go. That's it. I did the same for the other one, didn't I? Duh. Okay, Angular gods. Let me compile. There we go. Super. Okay, so I tell you what. Let's just put some console logging in here, just so we can see what's going on. Console.log, and let's just say point it down. Hush. And let's have a look at the event, just so we know these are definitely firing off. Got that one there, pointer move, and pointer up. Okay, just so we can see on the console what's going on here, and then let's also inspect this guy as well. And let me see if I can put it here. Let me use Windows Magic Snapping. I want that one there, I want this one here, and yeah, that's perfect. It's a little bit, maybe we can, a little bit down, there we go. We just really want to see the console, to be honest. Okay, save that, like so. Okay, when we click on, okay, we've got the pointer move. for absolutely everything, regardless of whether we dragged or dropped. We should also get a pointer down, which we do, and pointer up. Yeah, we can't really see those because they've zoomed past already. Okie dokie, so we know these three handlers are working now. Good to check those kind of things first. So let us implement something where we don't want to drag and drop everything. For example, these grid lines, we don't want to drag or drop them, but we do want to drag or drop the cubes. So what I'm going to do is I'm going to create a class on these, and I'm going to call this class equals, class I'm going to call, the class name is going to be draggable. You call it anything you want. It's just basically some way to flag whether we want to be able to drag or drop these things or not. And keep tidy. Let me just put this down on the next line so we can see it. Indentations, we like those. Okay, got the two of these guys, these two rectangles, and we've now given them both a class of draggable. So let's save that, so that won't change anything. But now we know there's something different about these two things, and we know that if we get the pointer down on something, we can look to see whether the thing that we clicked on has a class of draggable or not. If it doesn't, we don't want to do anything with it. If it does, we're interested in dragging it. So the way that we can see that is we use the event.target. So the event.target is the thing that we clicked on. So if we click on this, it'll be the event.target will be the rectangle. If we click on one of these, it'll be one of the paths that we created. If we clicked on one of these, it would be the text. So we want to say, we want to check the event.target if it's got a class of draggable. So to do that, we can do event.target.classList. That will give us all the classes in the thing that we clicked on, and then we can just use contains. And let's, if the event.target.classList.contains, and we want our draggable, if that is like so, then we are interested in dragging and dropping this thing. Let me just move this over a little bit. Yeah, actually, can I move this over? Thank you, Windows, that's very helpful. Okie dokie, so got that. So if it is one of those, let's store it in a variable, and let's call this selected element, because it's the element we've selected. Try and keep it simple. If it's a draggable thing, selected element, sorry, this, because we're in the Angular world, Angular, equals the event.target. Okay, so if you clicked on it and it's draggable, we want to know what it is. Your mouse is still down, and then when we move it, we know what we're moving. It should be this dot selected element. So let's do that. Cool. Okay. So the next step on this then is we want to say we only want to know about the point and move events when we've got something selected, right? So we've clicked on it, it's draggable, then we're interested in the movement. Otherwise, we don't care. We don't care if you're moving your mouse around the screen or not. So we can say if this dot selected element. So if we've got an element, let's copy all of that. If we've got something we clicked on that's draggable, then we're interested in it. Okay, cool. Let's do that, and then let's just check that that works. we should be able to see the console output. All these, yeah, you can see now the mouse move events have stopped, but if we click on one of these guys and now move it around, okay, that's fine. And we noticed that all this is getting selected, so let's do an event dot prevent default. That should stop that event bubbling up to the selection. So if we click on that now, bam, bam, bam. Okay, that's better. Cool. And we've got the pointer up as well. Okay. Okay, so next thing we want to do then is start trapping the mouse. So in this pointer move function, let's start getting the mouse position, and to do that we can use the event, which will be a pointer move event, and we can get the client X and client Y properties from that event, and that will give us the coordinates, the X and Y coordinates of where the mouse is on the screen. So let's do that. Let's say let mouse, come on, mouse position X equals event dot client X. Okay, that should give us that, and then let's mouse position Y equals event dot client Y. Okay, cool. And then let's just log these quickly because we can. We like to do logging each step. It's kind of, there are some scenarios where you can do debugging, and it's useful to actually put a breakpoint in. But when you're doing things that need to be kind of real time, it's just easier to console log them, and you can kind of see them as they go past console. Okay, we don't really need to know about that. We know we're moving it, and actually, when the pointer is up, we need to release this selected element because you've finished the drag effectively. So let's just move that up and set it to null. Otherwise, it still thinks there's a selected object or selected element. Cool. Save that, and let's check the console to see whether we are getting. Yeah, there we go. So position X, position Y. Okay. Cool. So next step then is we want to translate that to the X and Y of the rectangles. So we've got the selected element, which is the thing we clicked on. So this dot selected element, and then for SVG, we're not using set attribute. It's set attribute NS namespace, because the SVG elements are in a different namespace from HTML elements. So first argument is null. I can't actually remember what it could be. Maybe it's the namespace, but this works. X, we want to set the X position, and we want to set it to the mouse position X. Okay, so that should do it. And then we want to do the same for the Y as well. So this dot selected element dot set attribute, oops, went off the edge, set attribute namespace. Again, null, and this time we want to set Y, and then we want to put in the mouse position Y. Here we go. Mouse position Y. Okay, so let's see what happens when we actually move one of these bad boys then. Let's move it. Oh. Okay. That didn't work out very well. Why didn't that work? What is selected element? Oh, here we go. Typo. Sorry guys, that's real-time coding. Okay, let's try it. Two double T's, set attribute ns. Let's try that again. Okay. Okay. Well, it moves. That's pretty good, but that's not exactly what we wanted. And I will tell you exactly why that is. It is because the coordinate system inside the SVG and the coordinate system of the entire web page are different. The mouse's coordinates are for the entire web page, but the actual coordinates for the rectangular object are inside the SVG. So time for another amazing notepad. Woo! Do I want to save my work of art? No. So we've got the web page, which looks like this. Oops. And at the top we've got here, which is like x equals 0 and equals 0 and y equals 0, which is fine. When we move the mouse around, so we move it down here, it'll be like x equals 100. So maybe it'll be like 700 there or something. And then y equals maybe 500. So far so good. That's in the coordinate system of the web page. But then over here we've got our SVG, and inside here it's got its own coordinate system. And here inside the SVG we've got x equals 0 and y equals 0. And then maybe down here we've got something which is like x equals 300 and then y equals, I don't know, 250 or something. So we've got a different set of coordinates between these, the whole web page itself and the actual SVG inside the web page. So when we move the mouse and we say like x equals 700 and y equals 500, that's inside of here, which is only 500 pixels wide and 500 pixels high. X equals 700 is kind of off here somewhere, so that's why we see the erratic jumping around, and 500 is down here. So we need some way of translating the mouse coordinates for the entire web page into the mouse coordinates inside the SVG. And to do that, we use the CTM. And if you Google that, because I've forgotten what it stands for again, coordinates, SVG, CTM, coordinate transformation, current transformation matrix. Okay, there we go. So we can use that basically to find out where the mouse is and get the right position inside here rather than some random stuff from the whole screen. So let's do that without further ado. We want to get the position of the actual SVGs inside the parent object. So that will be, at the moment we got like this bit of padding here, right, which was like, I don't know, what did we say? The padding was 20 pixels, so it's 20 pixels on each side. So there was 20 here, there was like 20 here, and then there was some text at the top as well of the page, which is this text up here. So let's find out where it is inside its parent object, and to do that we can say, well, first of all we need to get a reference to this SVG object itself, and to do that in Angria, well, we can just use a view child actually. If you're doing it in vanilla JavaScript, you can use the just document.getElement by ID just to get it. In Angular, let's do this, SVG grid. Perfect. Let's do that. And then in the code itself, we need to create a view child for that. So at view child, And then on that, we need to say what we're... No, don't do that, please. That's very annoying. View chart. No, go away. Yes, thank you. What do we want to point it to? Well, it's looking at this thing inside here, which is effectively that kind of ID for it. View chart SVG grid, and then we want to say we want to call it by something inside our code. We're going to say it's an SVG grid, and we could tell it what type it is, and it's an element ref of SVG element. I don't know why it's double SVG. Didn't make it up myself. Okay, now we know what this is. We've got a reference to it in the code. Let's go down here, and then we will say get this current transformation matrix object from the SVG. So this dot SVG grid dot native element, which is basically the same thing as you would get if you're doing a document.get element by ID, but we're doing it in Angria, so we are using it that way. And then we want the get screen CTM. Okay, so that should give us some goodies there. And then we want to say the real mouse position inside the coordinate space of the SVG is the current mouse position minus the CTM, wait for it, dot E. Of course it is. Just, you could have guessed the property name, right? So that's for X. I don't know why it's called E. I guess, I don't know, these guys are probably smarter than me and I probably just don't understand. So we'll just live with that. And then the mouse position Y equals CTM dot F. Okay, fine. And then, sorry, actually we want to set them after we've changed the mouse position. So that should give us the X and the Y inside the SVG coordinate system, and then let us save all of that with Control K and S. Save everything inside Visual Studio Code. Okay, that was a long way around, but let's try it again. Okay, so now we are inside the coordinate system, but when we grab something, it immediately jumps to the top left, which is still not the desired result. The reason for that is we are saying the mouse position is exactly where I put it on the 350 200. If I put it on the 250 400, it will move the object, it will move the top left of the object to the position of the mouse, because it doesn't really know how far over the mouse is from the actual object, and it always references the object by the top left. So we need to do a little bit more work there, and we need to say, when I click on something, measure the distance from the top and the left where I clicked, and then when I move the mouse, try and keep that offset. So that will call on another beautiful paint diagram. I know you've been waiting for this moment. All right. So this is our SVG here, beautifully drawn. This is our SVG. We've got our triangle here. When we click on it, we are clicking right here, like so. That is our click. And we get a position which is X, let's say X equals 300 and Y equals 300, like so. But the coordinates of the top here of this are going to be X equals 280, and let's say y equals 270. So there's a discrepancy between where we clicked X and Y, and when we drag we want to maintain that distance between where the mouse is and the top left of the thing is. We don't want the top left of the rectangle to jump exactly to where the mouse is. We always want it to be this distance Y away and this distance X away from the mouse, so it always looks like it's maintaining the correct transformation. So to do that we need to find out what this distance is. So it's the distance where we clicked inside the thing from the top of the thing, and this distance here, which is where we clicked inside the thing to the left of the thing. So let's get these two guys, and then we can start doing something a bit more interesting. Hope that made sense. Okay, so what we're going to do is when we click down on the element, we are going to get the offset from where we clicked on the element with the mouse, and we're going to get the top left of the object, and then we're going to do the subtraction. So first of all, let's find out where the top left of the thing we clicked on is, and to do that we can use not the set target, sorry, not the set attribute, we can use the get attribute ns. We know what it is, so we can say let target position X, which is the target we clicked on, equals this dot selected element, and then we want the get attribute ns, oops, big S there, and then we want to say null, and I should really find out what that first parameter is actually. Maybe somebody can let me know in the comments. I should stop being so lazy. X, okay, so if we grab that, that should be the top left of one of the rectangles, which is one we clicked on, and let's do the same for target position Y, equals that, equals Y. So in our lovely paint diagram, wherever it is, that will give us this point up here, the X and the Y of here. Okay, we also know when we clicked on it, we need to get the mouse position as well of where we clicked. So if we clicked on this point here, we need to know that, and then we can do subtraction. But we also need to do that inside the SVG space to make things more interesting. So let's get the mouse position X, yeah, equals, so it's gonna be the it's going to be the event dot client X, which we've already used before, and let's mouse position Y equals event dot client Y. So this is going to be the X and the Y of the mouse inside the entire HTML window. We then need to translate that to the CTM coordinates. So let's grab that CTM again. Probably not the most efficient way of doing this, but let's just do it for the sake of this demo. We want the grid, which is this, what do we call it, .svg grid? Yeah, native element dot get CTM, that was the guy. So that will give us the coordinates of the SVG itself, and then from that we can say the mouse position X, oops, no, I didn't want to do that, mouse position X equals the mouse position X minus CTM dot, what was it, E for X, and then mouse position Y. minus equals CTM, and it was F, I think, look at my other code, CTM.F. Okay, so that should get us the mouse position now inside the SVG space. And then we can say that there's an offset. We can then calculate, now that we've got the mouse position and the top left, we can now calculate the offset between those 2 points, which should be that distance there. So let's create some variables outside of here so we can access them in the move function. Let's call this one offset x. Let's just give it 0 for now. I prefer initializing things if I can. And offset y equals 0. Okay, and then we can say that this dot offset x equals, so it's going to be the mouse position where we clicked. Let me draw that again. So if it's like this, it's going to be where we clicked, which is going to be always going to be greater than the top left if the y is kind of going down that way and the x is going that way. So it's going to be the mouse position where we clicked minus, if we're looking for x, this side over here. So it's going to be that distance. So we want to say mouse position x minus the target position x, and that should probably work. We'll see. This you can see my confidence level is mouse position y minus target position y. Okay, right. So we should now be able to get this offset distance, and then we should be able to factor that in when we're dragging, so it won't immediately jump to the top left. It will always give us that offset distance and it'll look like we're dragging from wherever we click the mouse. Save that, just see if it complains. No, not complaining. It will still work as it does before because we're not factored it into the mouse move events yet. So let's do that next. And then when we actually move the mouse, we need to say, it should be quite simple actually. Get the mouse position, client X, client Y, and then we should just be able to subtract it actually, I think. I think we should just be able to subtract the offset. So can we just say mouse position X equals itself minus this dot offset X, and mouse position Y minus equals this dot offset Y. I think that definitely, probably will work. Put it back. These work? No, it doesn't. I've screwed it up. What have I done? Okay, I found out what I did wrong. It was actually a super helpful IntelliSense typo. It's this. Get the current transformation matrix. Actually, it's the screen current transformation matrix we want. So, sorry, get screen CTM. That's the guy. And now if I save that, let's try that again. Okay, okay, that's a bit better. That took me a while to figure that one out. So you'll be glad that I paused the video. So that's all of this lot. I will put a link to the GitHub for this after this, finish recording this, and happy coding, Interneters. Peace.